Okay guys, we are going to graph radical functions today. Before we do that, we need to know what the basic form of it looks like. So our basic form that we're going to talk about is y equals the square root of x. Or you could write f of x equals the square root of x. They are the same thing. So I'm going to make an xy table for this. And I'm going to use 1, 4, 9, and 16 as my x values. And then I'm going to make a very long table or graph with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. Because my graph goes out to 16. And I only need to go up 4, and you're going to see that, but I'll just go down 4 as well, just like that. So that's my initial graph. It might be a good time to pause and write that down if you haven't yet. So then I would just plug in these numbers. If I plug in 1, the square root of 1 is just 1. So my first point is 1, 1. And then if I plug in 4, the square root of 4 is just 2. And then if I plug in 9, so I'd go over 4 up 2. If I plug in 9, I would get the square root of 9, which is 3. And so I'd go over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 3. Thank you. And then if I plug in 16, the square root of 16 is 4. So I'd go over 4 and up 16. Or sorry, over 16 and up 4. And then my other number I could plug in would be 0. And the square root of 0 is just 0. So I know it starts at 0, 0. If I plugged in numbers over here, like a negative 1, I would start getting imaginary answers. So that means my graph is going to start at 0 and just curve nicely like that. If you look at this, it kind of looks like half of a sideways parabola. That's because it's its inverse. So they're always going to have this nice shape. We're going to use that shape to graph these. So if I look down here, this should look sort of familiar. We did it with quadratics. The A in the front tells me how, like, this has a nice simple curve. And if it is a fraction, then it'll be wider. And if it is or taller, it will go zoom. And if it is a whole number, it'll be flatter. If it's negative, it'll flip, just like before. So instead of going in this nice direction, it will flip down to be the other half of the parabola. And then H, that's what the letter A will do. H will move it left or right. And does the opposite of what you think it should do, just like before when we were doing parabolas. And K moves it up and down. And doesn't do the opposite. It just does exactly what you think it should do. So that's all you need to know how to do. If I look at these examples we're going to do, I have a plus. I have no number on the outside, so it's just going to be that nice general curve. I have a +1 on the inside. That moves the opposite if I think it should go, so it will go left 1. And that +5 on the outside will move it up 5. So I go left 1 and up 5, and that's my new starting point. And then I just draw in this nice curve. It doesn't have to be super exact. That's all I want you to be able to do. If I look at this one, again, I have no number in front of the radical. This is my K. Even though it's not back here, it's still added to that. So that's my K. So it's gonna move down 2 this time, because that's a -2. And that -3 in there is gonna move it right 3, because it does the opposite of what you think it should do. So I would go right 3 and down 2, and still it is a nice nice little half of a parabola. Sometimes they call them shooting stars. The last thing is this one. This time we have a -2, so that's gonna flip it. And then that +2 on the inside is gonna move it left 2, and that +3 is gonna move it up 3. So I go left 2, up 3. That's my new starting point. And then that -2 is gonna make it a little bit flatter and flip that way. And that's all you have to be able to do. And now you have some practice problems. Ask me if you need any help.